This video covers the Day 2 portion of Lesson 11.5 on angle relationships in circles. We're not going to learn any new relationships in this section. We are just going to practice the relationships that we learned in Day 1. I really like this concept summary that you'll find in your notes packet because it has all the formulas in one spot. Anytime you want to find the measure of an angle in the circle, you should first ask yourself, where is the vertex of the circle? Is the vertex on the circle, inside the circle, or outside the circle? In the first picture here, when the vertex of the angle is on the circle, the measure of the angle is half the measure of its intercepted arc. So you can see in this first diagram, the arc is 120 degrees. Well, half of 120, if we take 120 and we divide it by 2, that's where we get the 60 degrees. In this picture, this is angle 2 right there, and angle 2 is going to be half the measure of that intercepted arc. So you can see once again, 200 divided by 2 makes 100. We can also go the other direction. So for example, if I knew angle 1 was 60 degrees, the arc is twice the measure of the angle. Or if I knew this was 100 degrees, 100 times 2 is 200. When the vertex of the angle is on the inside of a circle, like in this picture, the measure of the angle will be half the sum of the measures of its intercepted arc. The intercepted arc for angle 1 is 86 degrees, and then we also take the vertical angle's arc. So that's the 44. And you're going to add those up. 44 plus 86 is 130. So I add them up first. And then after we add them up, we take half of that value. And half of 130, 130 divided by 2, that's where we get the 65. Sometimes the vertex of the angle will be outside the circle. Notice in these diagrams, the vertex of the angle is outside the circle. When that's the case, the measure of the angle will be half the difference of the measures of its intercepted arcs. When it was inside, we did half the sum, we added. When it's outside, we'll take half the difference, meaning we'll subtract the arcs. Here, you can see in this first picture that the arcs are 202 and 78. The measure of angle 1 is half of the difference, 202 minus 78. As before, we would do this part first. 202 minus 78 is 124, and then take half of 124, or do 124 divided by 2, and you'll arrive at 62 degrees. Same thing for the other example that's formed by the two secants. Since the vertex is outside the circle, we can take half the difference of the arcs. 125 minus 45 is 80, and then half of 80 is where we get that 40 degrees. Let's add one more thing here to our chart. And this is going to go back to something that we learned at the beginning of this chapter. In addition to being on, inside, and outside the circle, it's also possible for the vertex to be at the center of a circle. And when that's the case, the measure of the angle is going to be equal to the measure of the intercepted arc. You can add this to the additional examples or tips to remember at the end of the lesson. There's a section that says additional examples, things to remember, tips. Add this. It's just kind of one more option in our chart. And for a picture, I'm going to draw a circle. And for the central angle, you have to be given the center of the circle. Don't assume something's the center unless it has a dot on it and it looks like it's in the center of the circle. Now, suppose this angle here inside my circle is 60 degrees. Well, the measure of the central angle is going to be equal to the measure of the arc. So the arc right here is also 60 degrees. We originally learned about these. These are called central angles, and you can find the notes on central angles in lesson 11.2. So this concept summary is going to be your best friend when you're working to find angles on circles, because every single possible angle on a circle you can find using one of these four relationships: on, inside, outside, or center. Look at where the vertex is and then choose the formula based on where that vertex is located. For our example 4, these problems are all multi-step. And when we do these multi-step problems, there's more than one way that you can do the problem. So you might think of this in a different way than I do, and that's okay. Just make sure that you're marking up the circle as you go. First, look at what the question is asking you to find. It's asking you to find the measure of AF, which I just marked right here in green. Notice first that I see this 110-degree angle, and notice that the vertex is on the circle. If we go back to our concept summary, when the vertex is on the circle, the measure of the angle is half the measure of the intercepted arc. So let's outline our angle right here, angle ABC. We can see that the measure of angle ABC is 110 degrees. And the measure of its arc, which is arc ADC, see how that arc is formed by the angle? Well, the arc is twice the measure of that angle. So 2 times 110 is 220 degrees. So this full arc there that I've outlined in red is 220 degrees. Now, this 160 that's already in the picture, the 160 degrees only goes from B to D. So that is the measure of BD. If we wanted to find the measure of AD, we could find that. Now, we don't necessarily need that for this problem, but if AD is part of that 220-degree angle, 220 is the big one, subtract the 160, and that makes a 60-degree angle. Now, if you look at the picture, 60 plus 160 gets us back to that 220 that we determined was the measure of arc ADC, using the fact that the vertex was on the circle. Well, now we actually have everything we need. If you look at your picture, we have almost the entire circle filled in. This little arc is 48, and then we have 160 and 60. And remember that a total circle is always exactly 360 degrees. Well, to find that missing arc now that I've outlined in green, the measure of arc AF, we can start with 360 degrees, which is our total circle, and then we can subtract the sum of the arcs that we already have. We have the 48, and then we have the 220, or if you want to break it up into the 60 and the 160, that works too. Add up these values. 220 plus 48 is 268. So 360 minus 268 is 92. That means the measure of arc AF is 92 degrees. For your try now, I'm actually going to talk through this problem. I think we could use one more example of a multi-step problem. If you'd like to try it on your own, feel free to pause your video and give it a try. Otherwise, keep listening. In this question, we're asked to find the measure of arc YZ. I'm going to outline the measure of arc YZ that we're trying to find here with my green marker. So that's my end goal. There's a lot of different ways that we could solve this problem, but the first thing that I'm noticing is that 113-degree angle in the circle. Notice that 113, we can actually get the other angles around it just by using like vertical angles and properties of lines. The angle directly opposite the 113 is also going to be 113. Those are my vertical angles. And then the angle next to it, it makes a line with the 113. 180, the full line, minus the 113 is 67. So these two remaining angles are 67 degrees. Now let's see if we can find the measure of YZ. Now, the first thing I'm noticing is there's a triangle right here. And if there's a triangle, we might not really need to use as many rules if we can use what we know about triangles. In triangle XYV, all three angles must add to 180 degrees. All triangles have an angle sum of 180. So let's add up the two angles that we have, 49 plus 67, and that's 116. And then I'll subtract that from 180. 180 minus 116 is 64 degrees. So this angle right here, angle XYW, or XYV, is 64 degrees. Now notice that angle too, if we extend this and we look at just the angle and ignore the triangle now, so I'm going to erase that marker. That angle there has its vertex on the circle. And we know that when the vertex is on the circle, the measure of the angle is half the measure of the intercepted arc. So this arc right here, WY, is just going to be double that 64. 64 times 2 is 128 degrees. And now with that, we have enough information to actually find that missing angle. The 128's the purple, 68 degrees is this section that we have. I'm coloring it yellow. And then the green is really just the rest of the circle. Just like the last problem, we know that our total circle is 360. So let's subtract the ones that we know. We know 128 and 68 are on the arches. That's the purple one and the yellow one. And when we add those together, we get 196. So 360 minus 196 is equal to 164. And that means this angle right here is 164 degrees. So measure of arc YZ, that arc is 164 degrees. And there we go. These multi-step problems can be pretty difficult. There's probably a bunch of different ways we could have arrived at the 164. That's just the way that I saw. You might see it a different way. Take your time when you do these multi-step problems, and if they're really, really challenging for you, I'll let you know that there are not very many of these on the test. The test for this unit only has one problem where you're going to have to use multiple rules. All of the other problems, you'll be able to just use one rule for each question. Thanks for watching, and good luck as you practice finding angles in circles. Remember to look at that concept summary that has all the formulas in one spot.